Good wishes, dear students. Today we will see extraction of copper from copper pyrite. The molecular formula for a copper pyrite is CuFeS2. There are different steps involved in it. We will go one by one. The first step is copper pyrite is converted into mixtures of copper sulfide and iron sulfide. Now, you have also know the method called roasting. Now, roasting is a method in which the ore is heated with the excess of oxygen. As a result, one of the byproducts will be sulfur dioxide. Now, copper pyrite, you are treating it with the oxygen, and I get here copper sulfide, iron sulfide and sulfur dioxide. Now, here copper is also metal. Iron is also metal, but between the two, iron is more reactive than copper. So, the oxygen that is involved, the whole amount of oxygen is not used up in the reaction. There are some leftover amount of oxygen. So, after the formation of copper sulfide and iron sulfide prefers to react with the oxygen, forming ferrous oxide and sulfur dioxide. Now, ferrous oxide and sulfur dioxide. Now, after ferrous sulfide reacts with the oxygen, copper sulfide prefers to react with the oxygen, forming copper oxide and sulfur dioxide. But when we compare the reaction of ferrous sulfide and copper sulfide with the oxygen, ferrous sulfide reacts more with the oxygen, copper sulfide reacts less with the oxygen, and that's what I've given the points for you all here. More amount of reaction, less amount of reaction. After the formation of copper oxide, it immediately combines with the leftover ferrous sulfide to give this product. Now this leftover ferrous sulfide, I get here ferrous sulfide cuprite gives me ferrous sulfide. Ferrous sulfide reacts with the oxygen to give me ferrous oxide. Now the whole of ferrous sulfide is not utilized in the oxidation. There are little more of ferrous sulfide unused. They combine with this copper oxide formed here to give you back the copper sulfide and the ferrous oxide. So, but immediately copper oxide formed here combines with the leftover FeS. You can just follow my arrow to give copper sulfide plus ferrous oxide. Now, the whole procedure A and B talks about a method called roasting. Now, after all this roasting, what we are left here is copper sulfide, ferrous oxide and ferrous sulfide. Copper sulfide, what you get here. Ferrous oxide also what you get as a byproduct. Ferrous sulfide, the one that reacts with a copper oxide. So these are the three products you have left over. Now we are moving into the third type of procedure. Now roasting is done. Next we move on to under extraction. The first step will be smelting. Now what's the meaning of smelting? The word smelting should give you the term called heating a metal at a highest temperature. Point number 2. The term flux slag should come into your mind. Now in terms of extraction of iron, instead of FeO, that is ferrous oxide, we had taken calcium oxide. Now in the extraction of copper, we take the ferrous oxide formed here to be flux, silica that is already present in the ore. Together flux plus gangue gives you slag being removed as a waste material. Slag is nothing, a waste material. Now, after that, we are moving into the next step. Now, copper sulfide, I'll show the page again here. You have, after the roasting, you have copper sulfide, ferrous oxide and ferrous sulfide. Ferrous oxide is removed as a ferrous silicate, meaning slag. Now, we are left over with copper sulfide and ferrous sulfide. Now these two combined together are called as a copper mate. So if the question is asked, define copper mate, is nothing. Combination of copper sulfide and ferrous sulfide is called as a copper mate. So now we did the roasting. Second we moved on to smelting. In the smelting certain amount of impurities were removed in the form of a slag. Then third we are moving on to Bessemer Isolation. Bessemer Isolation is another type of extracting the metal. So it's subjected to very high temperature. The furnace is coated with the silica. Now in the Bessemerization, copper mate we take. Where do we get this copper mate from? It's a combination of copper sulfide and ferrous sulfide. Silica, I told you. The furnace is coated with the silica. Plus we subject hot oxygen to it. Now there are three types of reaction taking place between them. The first one, you can just also follow my arrow. Ferrous sulfide reacts with the oxygen to give me ferrous oxide plus sulfur dioxide. Sulfur from here, oxygen from here form a sulfur dioxide, and oxygen from here and iron from here give me ferrous oxide or iron oxide, anything you can call it here. The second step here is the ferrous oxide formed. You can follow my arrow once again. Reacts with the silica. Now the silica is the one that is coated, being coated with the furnace. The ferrous oxide reacts with the silica to give me slag. That is, ferrous oxide is a flux taken here. SiO2 is a gang here. Together they give me a slag. That's a ferrous silicate waste material. The third type here is, now these two reactions are completely over. Copper sulfide reacts with the oxygen. Now here I get copper oxide plus sulfur dioxide. I already told you in the earlier description, copper sulfide does not react with the oxygen completely or to a major extent as iron sulfide reacts with the oxygen. So only little amount is used. The leftover amount is available in copper sulfide. So copper sulfide reacts with the oxygen. I get copper oxide plus sulfur dioxide. Please read what I have given it in the bracket for you all. Only some amount of copper sulfide undergoes oxidation. I have told you already. The leftover copper sulfide combines with the copper oxide formed here. So copper sulfide is from here. The copper oxide formed here is a leftover copper sulfide and a newly formed copper oxide. Together they react to give us something called a blistered copper along with the sulfur dioxide. Now what's the meaning of blistered copper? Now the copper that we get here is almost 98% pure. It is a pure in nature. Now what's the definition for blistered copper? The metallic copper is solidified. The copper that we get when we solidify, the sulfur dioxide packed within the molten mass of the copper. Sulfur dioxide gas gets out, but again some amount of sulfur dioxide gas will be mixed with the molten state of copper. Now it evolutes as a blisters, hence it's called as a blistered copper. Thank you.
I gave you my heart.